Hi, my name is Kavita, and I'm going to be presenting and telling you about how I optimize the volume of a rectangular prism with an open top triangular prism. So to start off with, I had to calculate the volume of the rectangular prism. So the volume of a rectangular prism is length times height times width. As you can see, this is L1, height 1, and width 1 because there's different lengths and heights within the object. The length is 6.8 centimeters and it actually equals to the width. And the height is 4.1 centimeters. So over here, I have the object and I've measured it, and that is the measurements I've gotten. As you can see, length and width will be the same. So afterwards, I also have the triangular prism. It actually is an open top, and unfortunately, I recently lost this, but I was fortunate enough to get the measurements. So the volume is half times your length squared times your height. And our length is actually the same, which is 6.8, because it actually went across here, but it was open because it let the fragrance smell. And then your height is 2.4, which kind of makes sense compared to over here to here. And so when I was calculating the total volume, I had to do the volume of the rectangular prism plus the volume of the triangular prism that was open top, and I multiplied all the values, and in the end the volume was 245.072 centimeters cubed. So after calculating the volume, I actually did the surface area as well. The surface area of a rectangular prism is 2 times W, which is your width times length, plus height times length, plus height times width. So further on in the video, I'll transform width into length for most of it because they're the same length, meaning they'll have the same maximum. So the surface area of the open top triangular prism was length times height times the side times the length. So this part was 1.8 centimeters, and unfortunately I don't have that. So the surface area for the entire object would be this plus this, as you can see right over here. And I've actually plugged in all the values, and in the end, I have 244.80 centimeters squared is our surface. So when I was optimizing the volume, obviously first I have the volume equation. So volume equals to the first volume plus the second volume, which means the rectangular prism and the triangular prism. So the equation, as you can see, as I've had before, is this. So what I did was I subbed in the ratio equation. So what I mean by the ratio equation is essentially this. So because we have so many variables, I made ratios, and all the ratios are being compared based on the height of the rectangular prism. So anything that has a subscript of 1 means a rectangular prism, and anything that's a subscript of 2 just essentially means it's the triangular prism. So we have S, which is, from our triangular prism. And what I did was you do S over H1. So it'd be 1.8 over 4.1. This is your ratio. So your ratio is 0.439 H1. Then the second one is I did it comparing the two heights, so H2 and H1. And 2.4 centimeters over 4.1 centimeters gives you 0.585 H1. And the last one is the length. So because I'm only doing L1 because L1, which is your length for the rectangular prism and the width, as well as the triangular base length, is the same because I've measured them and they are the same. And it doesn't make any sense to do it individually because they'll be the same at the end, and you just plug in it and it makes it easier. So it's 6.8 divided by 4.1, and you get 1.658 H1. So back to optimizing this. So when I said sub in your ratio values, basically what I did was I stated in the ratios that I have L1, I have H1, and I have H2, and I have S. So this is my first volume equation. So it's L1, W1, and H1. So because W and L are the same, I'm just going to make it L1 squared just to make our lives easier. So I have L1 squared times H1, which is our volume, plus 1 over 2 L2 squared times H2. Then I'm going to sub in our ratio value. So if we go back over here, we see that L1 is equivalent to this ratio. So essentially, L1, this equals to L1. So what I'm going to do is I'm going to make this equal to L1. So L1 will now become CH1. As you can see over here, that was the ratio. So now it becomes CH1. And because it's being squared, you're going to square it on top of that. And then you multiply it by H1. Then you add 1/2. And you do the same thing for your other length. Because remember, L1 and L2 are the same length. So that means they're the same. So you do CH1 squared times H2. And in the end, your result would be C squared H1 cubed plus 1/2 C squared H1 squared and H2. As you can see, now you have 3 different variables. So because of that, we want to optimize this. We're going to actually use a surface area equation to help us optimize the volume. So over here, you can see I have the equation that I discussed earlier. So with this equation, as you can see, is W times length. Width times length. Width and length are the same height. So same length, sorry. So you can just make it L squared like how I did for most of them. And then over here, W, just transform that into L because we are trying to work with everything for L1 because we want to make our lives easier. So this is going to become L1. And because it's HL1 plus HL1, obviously you can have 2HL1 and then L1 squared times 2. So over here, you can see that right over there. So then afterwards, you're going to sub back in what your, basically what our ratios were. So if you refer back, L1 equals to CH1. So over here, you have CH1 squared because it's L squared plus 2 H1. We already have H1. And then we have to multiply it by L1, which is CH1. After expanding it, you're going to get 2 in the brackets outside. And then you have C squared, H1 squared plus 2CH1 squared. So this is your total surface area just for your rectangular prism. I decided to break it up because it's so many steps. So now we're going to go on to our second surface area equation, which is our triangular prism. So first we have our equation for it. And as you can see, everything's in L. And we also have S. And as you can remember, and we go back to our ratios, we actually did find a ratio for S. So S equals to AH1, which you'll see over here. So my equation is LH2 plus 2SL2. So L2 subscript is basically L1 subscript. So it's all the same length as I've said. So I'm going to sub in the value CH1, which is L1, times H2, which is right over there, plus 2 times AH1 times CH1, because AH1 is our S value and CH1 is our S and is our L value. So after expanding it all, you're going to get CH1 H2 plus 2ACH1 squared. So now we're going to add both our surface areas because this is our final one for the triangular prism, and this is our final one for rectangular prism. After adding all these numbers together, in the end, what you get is 2C squared H1 squared plus 4CH1 squared plus CH1H2 plus 2ACH1 squared. Now, that's a lot to take in. So we're going to try to isolate for H2. And what we're going to do first is we're going to bring it all to the other side. And look at this. There's only one of these numbers that has H2, which is this. So we're going to get that by itself, and we're going to bring everything else over here, which we did. So now we have CH1, H2 by itself. Okay, now we just want to get H2 by itself. So that means we're going to divide it by CH1. And essentially this is what we're going to sub in to the equation afterwards. So we can derive it and find our optimized volume. Okay, since our main goal for this whole entire time was to find our maximum height and then get our maximum volume, I mean basically just optimize it, what we're going to do is, so we know that H2 equals to this equation right over here. But we also know our volume equation was originally this when we substituted our ratios, if you can refer back to previously. So when we substituted our ratios, this was our equation. So now we're going to use this equation and actually, you can see over here, this is H2, but we found out that this equals to H2, as you can see here. So with this equation, we're going to sub in this H2 as this. So what you do is here, you sub in that. So surface area minus 2C and etc. So after doing that, you can see that this is C squared, H1 squared, and this is CH1. They can be canceled out, and that will get rid of your fraction, which is amazing. So after you get rid of your fraction, you still have CH1 remaining. So this is your equation afterwards. Then you're gonna try to get common things together, and at the end of doing that, you're gonna have in the result C squared minus 1/2 C times 2c squared plus 4c plus 2ac. And you can remember this from here, which is basically that. Then you have h1 cubed on the outside. At the end of the day, this will multiply this with that, with that. So all of them are multiplying together and adding, and you will still get that end result there. So then afterwards, you have plus 1 over 2 c surface area h1. Okay. Now you have this. This is where your calculus skills come into play. And now you're going to derive this equation. Now you can see how this is so long. So I decided to call this Z. This makes our life so much easier. And when we go back to it, we can just use that equation to solve for Z. So you have Z H1 cubed plus 1 over 2 C surface area H1. When you derive this, 3 comes down. You do 3ZHY. You do n minus 1. So 3 minus 1 is 2. And then this is another one of our, another one of our derivatives that we have to do. So H1, so 1 comes down, so it's still 1. And then you do 1 minus 1, which is 0. So 1 to the power 0 is 1. So what you end up is 3Z H1 squared plus 1 over 2 C surface area. Okay. Now, you're going to set it equal to 0. You're going to do that because you want to solve for h, obviously, and then you can find your volume. So after doing that, you're going to put it to 0. You bring this to the other side. Then afterwards, you divide it by 3z to get h1 by itself. You square root it to get h1 by itself. So if you recall, I call this z. Now, this is our final, our square root. So over here, you can see that we're doing negative c times surface area over 6z. At the end of the day, when you square root that, you're going to get a negative answer. So to refrain from that, you're going to plug in all your c, your surface area values, and your z values. So we know that our c values are 1.658, and our surface area is 244.80 centimeters squared. You put the negative outside. Then, if you recall, this was our z value, and I told you we'd come back to it, and this is what it made our lives easier. So let's go back to our z value. This is our z value. You're going to plug in all the numbers that you have in your ratios, which is basically right over here, your C and A, sorry. You're going to plug it in over here, anything you need. And then afterwards, you're going to get your final answer, multiplied by 6. You're going to get 405.87 divided by, so they're all negatives, divided by negative 51.07. Negative cancel out. You get 7.94. You square root that. You do positive minus. Obviously, if it's a negative, it's an extraneous root, so you want to include that. So your positive value is 2.81. That is your optimized height. Now you're going to go for the rectangular prism. Now you're going to go find the optimized other units for everything else. So the optimized height for your triangle prism is 1.64. And if you're wondering how I did that, basically what I did is, if you remember, once again, this is our ratios. This is our ratio, 0.439 H1. So what I did was, H2 is this. So 0.585 H1. So I do 0.585 times 2.818, get 1.64. Same thing, length, it becomes 4.672 centimeters. And then S becomes 1.237 centimeters. Okay, so now for your optimized volume, what you do is, so I just did to break it up like how I always do. I calculated it for the volume for the rectangular prism. It came out to be 26.33 centimeters cubed. Then for the triangle prism, it came out to be 17.898 centimeters cubed. In the end, when I add them both, 44.22 centimeters cubed is your volume. That is all. So essentially, this is all your optimized volume, and that's the steps to getting there.